Okay students, welcome back to the online EGDL classes. We finished with the projection of straight lines in the last video. So when we discussed the projection of a straight line, I said the straight line is unidimensional. It has got just length, that's all, only one dimension. Now we are moving to a new topic which is projection of planes. A plane, as you know, is a 2D object. It's two-dimensional. And if you remember in drawing number 1, under geometry constructions, you have learned how to draw various polygons in various positions, starting from a triangle and ending with a hexagon. So these are the polygons or the planes that we are going to discuss in this topic, projection of planes. So this is the title or the heading that you have, projection of planes. I have drawn various planes here, okay, starting from a triangle, square, a rectangle, a pentagon, a hexagon, and then a circle. So these are the planes that we are going to deal with in this unit. Now, a plane is also called by the name lamina. Sometimes we use a plane, or sometimes you can also use a lamina in place of a plane. Now here I have named the corners like this: A, B, C, A, B, C, D. Okay, A, B, C, D, E and so on. The corners have been named. Now let us see what are the terms used with reference to a plane or a lamina. I have written them here. A, B, C, D, they represent corners of lamina. Okay. Then AB or BC or CD, AB, BC, CD, etc., they represent side or edge of lamina. Okay. Sometimes we use side, sometimes you can also use edge of a lamina. Then what is ABC? ABC? ABC is the surface of the lamina, or I can say it is the lamina itself. Okay. Similarly, ABCD is the surface of a square lamina or a rectangular lamina. ABCDE is the surface of a pentagonal lamina, and so on. Okay. So there are three terms that are used with reference to a lamina. One is the corner of the lamina. Okay. The second is edge of the lamina or side of the lamina, and the third is the surface of the lamina or the lamina itself. Okay. So these are important to know. Now under projection of planes, you have 4 drawings. Drawing number 4 we have finished already in projection of straight lines. Drawing number 5 is an assignment to you. That we will not be doing in the class. You need to do it on your own. Now we will move to drawing number 6. Drawing number 6, drawing number 7, drawing number 8 and drawing number 9 are under projection of planes. Now each of these drawings are put under one simple position. For example, drawing number 6 is on simple position 1. That we will discuss now. Okay. After discussing what is simple position 1, then we will move on to drawing number 6 and solve the 3 problems included in that. Okay. That's what I am going to include in this video. So let us move to simple position 1 now. Let me explain what it is. Okay, let's move to drawing number 6 now. This drawing is based on simple position 1. There are 3 problems under this drawing. All the 3 problems are under simple position 1. Before I explain you what is simple position 1, let me briefly tell you how we generally solve a problem on projection of planes. Normally, a problem on projection of planes is solved in 3 steps. The first step will be always a simple position. there are four simple positions in projection of planes. So your first step will be one of these simple positions. So you should know which simple position you have to adopt. Is it simple position 1, 2, 3 or 4? This is required. This you should know. Then in the remaining two steps, you will be satisfying what are called as HP condition and VP condition. Okay. Shortly we call them as HPC and VPC. You also should know which condition to satisfy first. It depends on which simple position you are adopting. Okay. So this is the knowledge which you require to solve a problem on projection of planes. So basically it is solved in three steps. The first step will be one of the simple positions. The second and third steps you will be satisfying what are called HPC and VPC. Sometimes we satisfy HPC first and sometimes we satisfy VPC first. You will learn as we proceed. Okay. So drawing number 6 we have taken now. There are three problems which we will solve in this video, and all the three problems are based on simple position 1. Yes. Now let me explain what is simple position 1. To make it simple to you, I have taken up 4 questions here to explain you what is simple position 1. Okay. So this drawing number 6 or D6, simple position 1, shortly we call it as SP1. The first question is, what is SP1? It says a lamina resting with its surface on HP and one of its edges, preferably the right side edge, perpendicular to VP. This is how I have to place my lamina. Okay. How should I place? There are two conditions. One is it is resting with its surface on HP. Let us say this is a square lamina. It has got 4 edges and also 4 corners. If you call it as A, this is B, this is C and D. So AB is an edge, BC is another edge, CD is another edge, DA is the 4th edge. And totally ABCD we call it as the surface of the square lamina. And for the lamina, this dimension, the thickness, is neglected. So we take this to be just a line. Okay, the thickness is neglected for the lamina. Okay, so having understood the plane, okay, let me show you what is this simple position 1 and how should I place the lamina to adopt simple position 1. What is it? One is the surface is on HP. This is the surface of the lamina. This surface I should keep on the ground or on HP. So should I place it like this? Should I place it like this? How should I place it? Look at the second condition. One of its edges, preferably the right side edge, should be perpendicular to VP. Let us say the lamina is like this. When I place it like this, this is the right side edge. Okay. The condition says this right side edge should be kept perpendicular to VP. This line should make an angle of 90 degrees with VP. So this is how you should place the lamina on HP. Okay. What is the first condition? The entire surface should be there on the ground. And the second condition is that this right side edge should be taken perpendicular to VP. So that is SP1, simple question 1. Okay. Now, when to adopt is the second question. When to adopt simple position 1? In other words, what should be the condition given in the problem for you to adopt SP1? Depending on the problem, you have to select which is the simple position. Okay. So, what should be the condition given in the problem for you to adopt simple position 1, or what prompts you to adopt simple position 1 is the question. This is the condition that should be given in the problem. What is that? When a lamina is resting with one of the edges on HP. It has got 4 edges. One of the edges must be resting on HP. that is one condition, and surface inclined to HP at an angle theta. This should be the condition given in the problem for you to adopt SP1. What is the condition? One edge should be on HP and then the surface should be inclined to HP. This should be the position given in the problem. What is the position? One edge should be on HP. Yes, I will place it on the ground and then I will make the surface inclined to HP at an angle theta. So when this is the condition given to you in the problem, okay, you should adopt SP1. And what is SP1? This is SP1. You are keeping the entire surface on HP and you are taking one of the edges perpendicular to VP, preferably the right side edge. You can take this edge also. I prefer to take it on the right side. I will tell you why. There is some advantage. Okay, now you have understood what is the condition given in the problem and what is SP1 you have understood. Okay, what is the condition given in the problem? Like this. This is the condition given. One edge is on HP and surface is inclined to HP. Now, why can't I start straight away with this condition? Why should I adopt this as the first step? Okay. When the lamina is like this, placed like this, it is very easy to draw the top and front views. Can you tell me what will be the top view in this position? When you look from the top and when I project it on HP, what do you get? You get a regular square. Okay. Then what will be front view? The front view is just a line. And because you are keeping the surface on HP, this line appears to be on XY line. When you project the surface on to VP, okay, if it is lying on HP, when you project it on VP, that it will go on the intersect XY line. That line will go on intersect XY line. Okay. So the top view is a regular square in this case, and the front view is a line, and the line appears to be on XY line because the surface is on HP. So it's quite easy to draw the top and front views in simple position. But can you draw the top and front views for this? When I project this, in this position on the ground, it's no longer a square. It will not be a square. Okay? So you can't draw, you can't start by drawing the projections for this position. This is the actual position given to you in the problem. I am not able to draw the top view because it's not a regular square. Though the front view is a line, this still remains to be a line. The line appears to be inclined to XY. But I can't draw the top view. That is the reason why, though this is the condition given to you in the problem, as a first step, I start with this position, which is called simple position. This is what you should understand. Okay. So, in total, if this is the condition given to you in the problem, you are going to start with simple position 1. So these two are done now. Now, what is the next, the third question? How to start? How to start in the sense, should I start by drawing the top view first or the front view first? That is the question. Okay. So here, as I have shown you, this is simple position 1. The top view is going to be a regular square. That is why I'll start by drawing the top view first. That's the answer. Start by drawing the top view first. This also you should know. So whenever you are solving a problem with SP1, you should know that you have to start by drawing the top view first. So the top view you are going to draw as a regular square, and you will project it and draw the front view as a line. Then, what is the fourth question? How do you proceed? As I already mentioned, in any problem you have to satisfy simple position first, then the other two conditions, HPC and VPC. So when you adopt simple position 1, should you satisfy HPC first or VPC first is the question. This is the answer. This is the chain. You will satisfy SP1 in the first step. In the second step you will satisfy HPC, and in the third step you will satisfy VP condition. This is going to be the order. Okay. So this is all about SP1. So if you know this background of what is SP1, then you can solve any problem on SP1. Okay. Basically, these 4 questions, you can put these questions to yourself and you can answer them. Once you answer them, you will be able to solve any problem on simple question 1. We are going to solve 3 problems now under drawing number 6, and all will be on simple question 1. So when you read a problem, you should have an idea of which simple question the problem belongs to. As I mentioned already, there are 4 simple questions in projection of planes. So there are 4 drawings. Drawing number 6, 7, 8 and 9. Drawing number 6 deals with SP1, simple question 1. Okay. So having understood this, let me start with the first problem in drawing number 6. Let me read out the problem for you. You are in drawing number 6, D6 and SP1. The problem number from the CMRT question bank is 2.3.1, and from VTU question bank it is number 6, problem number 6 in projection of planes. This is the reference number from VTU primer. A 30 degree, 60 degree set square. Set square is nothing but a triangular lamina. Okay. 30 degree, 60 degree set square, in the sense it is a right angle triangle. Set square is a right angle triangle. 2 angles are given, 30 and 60. The other is 90 degrees. So it is a right angle triangle. In other words, it is a triangular lamina. Of 60 mm longest side. That means the length of the hypotenuse is given as 60. Okay. So using that as the hypotenuse, you have to get the remaining 2 edges, maintaining angles of 30 and 60. Okay. Is so kept that the longest side is on HP. That means the hypotenuse of the triangle is on HP, making an angle of 30 degrees with VP. The longest edge is making an angle of 30 degrees with VP. The set square itself is inclined at 45 degrees to HP. In other words, the surface of the triangular lamina is inclined at 45 degrees to HP. These are the conditions given in the problem. Draw the projections of the set square. Now analyze the problem. As I already mentioned, split it into 3 parts. The first part is simple position, the second part is HP condition, and the third part is VP condition. Let us identify all the 3 and then let us solve the problem. First of all, I should identify to which simple position the problem belongs to. Of course, I already mentioned that it is under simple position 1. Let me tell you how do you decide that it is under simple position 1. What did I tell you some time back? I said simple position 1 is there are 2 conditions to be satisfied. One is one edge should be on HP. The second is the surface should be inclined to HP. Okay. This is a triangular lamina. Okay. This is not a right angle triangle. It's a equilateral triangle. But this is a triangular lamina. Let us say this is the hypotenuse. Okay. So what should be the condition given for you to adopt SP1? 2 conditions. One is that this hypotenuse should be on HP, or one edge should be on HP, and then the surface should be given inclined to HP. If these 2 conditions are there in the problem, then yes, I am decided that it is SP1. Okay, I repeat once again. Of the 3 edges of the triangle, one edge should be on HP, and then the surface should be inclined to HP. If you find these 2 problems in the problem, then you can say the problem belongs to simple position 1. Where are they? Let me show to you. One is that the longest side is on HP. The longest side is on HP. Longest side is one of the sides. It is on HP. You find that. Then the set square itself is inclined at 45 degrees to HP. That means the surface is inclined to HP. So you have both the conditions what are required for SP1, That's why I said this problem belongs to SP1. Okay. Whatever I have underlined, because of those two conditions given in the problem, okay, I said this problem is under simple position 1. Done. So having decided simple position 1, that is the first step, what is HP condition? This itself is the HP condition. The set square is inclined to HP at 45 degrees is the HP condition. Then what is VP condition? The longest side makes an angle of 30 degrees with VP is the VP condition. This is how you have to analyze the problem. Okay. Simple position, HP condition and VP condition. And because you know that you are going to adopt, this problem belongs to simple position 1, you know how to start. You have to start by drawing the top view first. Then which condition do you satisfy first? It is the HP condition that you have to satisfy first. And then you move to VP condition and complete the problem. So the problem is going to be solved in 3 steps. That's why I made the XY line big here. Even when you solve this problem in your sketchbook, please keep the sketchbook in landscape position. Don't keep it portrait. Okay, you should keep it in landscape position, this position. Your sketchbook should be in this position so that you can draw your XY line here in the middle of the sheet, and so that you can accommodate all the 3 steps. Even in the examination also, okay, projection of planes and projection of solids, you will keep the sketchbook in landscape position and do it so that you can accommodate all the 3 steps. That's also an important thing. You can draw your XY line in the middle of the sheet so that you can accommodate both top and front views. Top view will come below XY line, front view will come above XY line in first angle projection. You know that. Okay. Now it is decided that this problem belongs to simple position 1. Okay. What is simple position 1? You must start by taking the right side edge perpendicular to VP. Perpendicular to VP in the sense you should take it perpendicular to XY line. Okay. Then let us say this is the right side edge. You are taking it perpendicular to the VP. So when you draw it on the ground, that line will come perpendicular to XY line. Is it not? Okay. It's like this. I have made sure that this right side edge is taken perpendicular to VP. When it is perpendicular to VP, when I project it on the ground, I get that line perpendicular to XY line. That's what you have to start with. It's given here, the longest edge is on HP. So whatever edge is there on HP, you are going to start by taking that edge perpendicular to XY. Understood? Whatever edge is there on HP, you are going to start by taking that edge perpendicular to XY. So this is going to be my first step. If you take this to be the hypotenuse, this is how I place my lamina and draw the top view. And what will be the front view? When you look from the front, it appears to be a line. And because you are keeping the surface on HP, the line appears to be on XY line. Okay? Let me draw and show to you here. The hypotenuse is given as 60 mm. So I'll start by drawing the hypotenuse perpendicular to XY. 60 mm. Then you will complete the set square using 30 degree and 60 degree angles. So take your protractor, keep it here, mark an angle of 60 degrees and draw a line here. This angle is 60. Some length, you can choose any length. And go here. Now here you take an angle of 30 degrees and draw another line. Wherever they intersect, this angle will be automatically 90. This is 30. This will be 90. And this dimension is given to you, which is 60. The other dimensions need not be, dimensioned. The other sides need not be dimensioned. Okay, only the hypotenuse is given. You can dimension that. And it's very important that whatever dimensions are given in the problem should be reflected here, should be shown here. And whatever the angles given also should be shown. If you don't show them, then you will be losing marks. For example, 60 mm is given here, so I must show it. This is one possibility of drawing the set square. The other possibility is, you can also draw like this. If this is 60, you can take 30 degree here also. Okay, 30 degree from here and 60 from here also you can draw. 60. This will be 90. This way also you can draw. Okay, it's not necessary that you have to draw like this. This is also accepted. The only condition is that hypotenuse must be taken on the right side and it must be drawn perpendicular to xy. With that you can complete the set square this way also. So we don't know what is the length of these edges. Let us not bother. It's not required for me. As long as the angles are correct. This should be, one of the angles should be 30 and the other should be 60. Now let me name the points. You are going to keep this edge on HP. Okay. So I'll start by naming from here AB. A, B, C. Why ABC? Why not A dash, B dash, C dash? This is the top view. You get the actual lamina you see in the top view. Okay. So this is the top view. So we use ABC. When I project it, as I mentioned already, it appears to be a straight line and the line appears to be on XY line. So this is your front view. Now this is the position of the observer. Observer, object and plane of projection is the order in first angle projection. The observer will be able to only view only B. A will be invisible. So I write A in brackets. A dash, B dash and this is C dash. So this is your SP1, simple question 1. Okay. If I show it to you in space, it's like this. This is your hypotenuse. Okay. One of the angles is 30, the other angle is 60. This is how you have placed in space. So you are able to see the actual lamina in the top view, and in the front view it appears to be a line. This is what I have drawn. Now I will move to the HP condition. What is the HP condition? One edge should be on HP and the surface should be inclined at 45 degrees to HP. So I must rotate the lamina about this right side edge. So I am rotating it like this. For this position you have to draw the projections, which is the second step. Or in other words, you are satisfying HP condition. Okay. So how to do that on the drawing sheet? You started with top view, you have come to first front view. Now this line, whatever line is there, I am going to rotate like this about this point. This is the center of rotation. Okay. So I move to the next step, second step, and I draw this line. This is nothing but the surface of the lamina. It appears to be a line in the front view. ABC is the surface of the triangular lamina. This line I will draw inclined at 45 degrees to HP or 45 degrees to XY. Make sure that this point is there on XY because AB is on HP. AB is the hypotenuse. Okay. So I take a point A dash, B dash on XY and draw this length. The same length. You can take this length with compass and draw that line inclined at 45 degrees. This is C dash. Same length. This length should be equal to this length. That is very important. No change in length. So the same line I have drawn inclined at 45 degrees, making sure that the edge AB is on HP. Now I can project and see how the top view appears. Now I can get. Okay. When the surface is inclined to HP at 45, how does the top view appear? I can project and get it. So draw a projector from both the points A and B. And then what you have to do? You have to draw locus from A and B. This is the locus of A and this is the locus of B. Locus means draw a line parallel to XY. Wherever the projector and the loci meet, you can, wherever the intersection points can be named as A and B now. This is the projector from A, this is the locus of A, wherever they intersect you get A. Projector from B, locus of B, wherever they intersect you get the point B. Similarly, you can get point C. Draw a projector from C, draw the locus of C, wherever they intersect you get C. So these projectors and the locus line should be drawn light. You should use 0.13 when you use the software. When you are using your sketchbook, draw them as light lines, using less pressure. Now if you connect these 3 points, A, B, C, you get the top view in the second step. This is how the top view appears in the second step. Okay. In this, if you closely watch, there is only one edge in its true length. Which edge is that? AB. Whatever is the length of AB here, it remains to be the same here. There is no change in length. But these two edges are shrunk in length. Their length is reduced because they are in apparent length. Okay, they are not in their actual length now in this position. The edge AC and CB are not in their true length or actual length. Here all the three are in actual lengths. But by the time you move to second step, where you satisfied the HP condition, HPC, okay, only one edge is in its true length, the remaining two edges are in their apparent length. Okay, because you are taking it like this. This is the edge AB. Okay, this is A, this is B in the first step. The second step, you have rotated the lamina like this. So AB remains to be the same when projected. Whereas this edge and this edge, when projected on the ground, okay, are shortened in length. Done. So you have satisfied the HP condition. You got this view. Now you are left with VPC, vertical plane condition. What is VPC? The longest edge is inclined at 30 degrees to VP. This is the longest edge. Right now it is perpendicular to VP. So when you move to next step, you must draw the same triangle, whatever you have here in the third step, with AB inclined at 30 degrees to XY. So you have to rotate it like this, so that this edge AB is made inclined at 30 degrees to HP. Okay, so let me start by drawing a line inclined at 30 degrees to XY. This is 30 degrees. And then you can use your compass. Take AB, the length of AB, which is equal to 60, and mark on this edge. AB. You can mark it anywhere on that line, but the length has to be 60. Now with this as one of the edges, you must complete this triangle here. Okay, how do you do that? You can just use your compass, measure BC, okay, take it with compass, with B as center, draw an arc, just draw an arc here. Now measure AC with compass, take A as center and AC as radius, cut this, so that you get point C. You are just constructing a triangle, okay, the same triangle. Very important, you should not construct this triangle there. Whatever triangle you have got after satisfying the HP condition should be drawn here. Understood? You shouldn't change the dimensions. You can change the position, not the dimensions. That's very important. Okay. So, after getting the point C, maybe so that is the top view now. So you are satisfying VPC here, vertical plane condition. What is VPC? VPC says the hypotenuse is inclined at 30 degrees to VP. After having done that, you can get the front view now. Now this is the locus for A and B in the front view. So project A and B till the locus in the front view. This should be B dash, this should be A dash. Similarly, this is the locus of C. Project C to the front view. This will be C dash. So this is how the front view appears in the final step. So the problem is solved in 3 steps. This is SP1, this is you have satisfied HP condition, and this is VP condition. So finally this is how the lamina appears. This is what you are asked to draw the projections for. You are asked to draw projections for this. To get this, I had to come through 3 steps. So in this step, all the conditions given are satisfied. What are the 3 conditions? One is that the longest edge is on HP, AB is on HP. The second is that the surface is inclined to HP at 45 degrees. Okay? The surface you have made inclined at 45 degrees to HP. Now, how do how are you sure that the surface is inclined to HP at 45 degrees here? Can you say? How do you verify that here the surface is inclined to HP at 45 degrees? This is how you can verify. When this is inclined at 45 degrees, this is the shape that you get in the top view. I retain the same shape here. I retain the same shape. I have not changed any of these dimensions. That's how I can say that the surface is inclined at 45 degrees to HP. And then what's the third condition? The longest edge should be inclined at 30 degrees to VP. That is satisfied. So in this step, all the 3 conditions are satisfied. AB on HP, surface inclined at 45 degrees to HP, the longest edge inclined at 30 degrees to VP. All are satisfied in the last step. But to get this step, I had to travel through 3 steps. I had to move through 3 steps. That's it. That is about this problem. Okay. Any problem on projection of planes, you will adopt the same procedure. We'll start with simple position, satisfy either HPC or VPC, and then the other condition. But as long as SP1 is considered, you will satisfy HPC first. You will always start with the top view, satisfy HPC first and then VPC. That is the flow. Okay. Let's move to the next problem under drawing.